Hey guys, in this video we will see about maps and structs. In our previous video we covered variables, basic data types such as string, int, boolean and float. Also we had covered couple of composite data types such as arrays and slices. In this video we will look into maps and structs. First we will look into maps. Maps are basically a data structure which represents hash table. So it allows us to supply key and value. Basically you could look into maps as an dictionary, and using this in Go is pretty straightforward. So the syntax for using maps in Go is you could define your variable, let's say stats. This is our variable name. You could use the shorthand operator, a keyword called map, and in the bracket you need to specify the key data type, and then here it should be the value data type. You could supply the value in the curly braces here, which will be key colon value in the format. The other way is you could leave this blank and then you could use the variable and you could provide some key equal to value. Okay, in order to display also you could use this format, so you could display a corresponding value for a corresponding key. Okay, so this is how we use maps. For structs is basically a data structure where we can contain many fields within it. Go is not an object oriented language, and the only way for you to contain different kinds of values in Go is by using struct. The syntax for struct is type, the name of your struct followed by keyword struct, and within this you could supply your field name colon the value. Okay, you don't have, so you could supply this. And initializing a struct is similar to how you initialize other variables, that is where variable name and followed by the struct name. In shorthand operator it would be var name colon this struct name, and you could supply the field value, etc. Okay, so it's very simple. So let us look this in action. So what we will do is we will open our VS Code. So I have my VS Code open here. Let us create a file called maps.go. And let us create our skeleton, that is main method, and within is, let's say we want to define a map of type of variable called stats. So we could do stats shorthand operator map. Here we need to supply the key data type, that would be string in our case, and for the value data type it would be integer, and we can supply the value either here in the format of let's say followers, let's say 1000 and so on. Okay, so currently I just have one value. Let's say I want to add some more, I could do it using stats. I could supply something like stats subscribers equal to 10,000 or whatever, right? In order to print this you could do fmt.println and you could give the stats. You can run this and you would see it's of type map, followers 1000, subscribers 10,000. If you want to print a particular value, then you could just supply the key in the bracket. Let's say I want to print followers, and if you run, you would only see the value of the followers. Okay, so this is with respect to maps. Also, there are various more methods that are available. Like if you type the variable stats and press dot, you have a way to print keys, get through the range, etc. Okay, so these are the different methods that are allowed. So we'll not go much into detail of this because there could be various variants of how we use maps, and we will see this during our uh, problem solving case, which we'll have later in this series. Okay, so next we will look into structs. So what we will do is we'll create a structs.go file. Let's initialize our main method, and we could start defining our struct. So what I'll do is I'll define structs outside of main. Okay, so the syntax is type the name followed by struct keyword, open, and here we can define our definition. Let's say I have name field which is of type string, I have age field which is of type integer. Okay, so I have a struct of employee which has two fields, name and age. In order to initialize, what we could do is give a variable name, E1 in our case, followed by employee, which is the struct name, and the field. So I have a field called name, so I can give the value, let's say John, and we have age, let's say 50. Great. So now Go is complaining that E1 is declared but not used, so let us print this up. So let's use the println that we have used in all our previous use cases and see what it prints. So go run structs.go. If you notice here, it prints John and it prints 50. So those were the values that we had supplied for name and age, but it is not printing the fields for us. So how can we even print fields? So for that we have various options available. So the first option what we could do is let's use the printf function, which allows us to define a format in which we want certain things to be printed. So let us see the printf method. So if you notice, the printf method takes a format. So let's say the format is first %v and we supply E1. Okay, and what I'll do is I'll just put /n so that there is a line after the print. If we run this, you will notice the output is similar to our previous println method. This is the default format. But this still doesn't solve our case where we want to print the field name. In that case, you could use the same printf %v. Okay, but what we need to do now is we need to give a plus sign before the v and after percentage. Now if we run, you will notice it prints the key as well as the value. Great, so this is what we wanted. Now there is another extension here, so let me just copy this and paste. Instead of plus, if we give hash symbol, then it will also print the struct name for us. If you notice now, it prints the package, it prints the struct name along with the field and the value. Okay, so these are the three variants in which we could do. The other option is we could create a JSON out of this struct. So for that, we will use a package called JSON, which is inbuilt in Go. So type JSON, press enter, dot, there is a method called Marshal. Okay, and this Marshal method takes any as an object and returns a byte and error. So what we will do is we will give in our variable name, and let's capture the return values into two variables, that is e1 JSON colon error. Okay, now it complains that both error and e1 JSON is not used. Okay, so what we can do is first, if error not equal to nil, meaning if there is an error while marshalling, we could use the log package fatal f and we could just print that error. Now let's say suppose you don't want to use this error and you don't want to make any business logic and you want to suppress it, then you could just replace this error with underscore. In that case, you would not need to handle, or if you don't care about the error etc, then you could just suppress it using underscore. But in our case, I will keep it so that we have a better way of demonstrating our example. So as we saw, it was returning a byte, right? This is a byte. So if we have to print it, let's say we do a print ln, okay, and we could just well, let's use the printf itself. Okay, in printf we will use %, I'll say it is a string, that is s, and I'll need to convert the byte into string. So we could typecast using string and give our e1 JSON. Great. Let me also use /n so that it prints in the next line. Now if you notice, it gives us a very nice JSON here. Okay, so this is one way. Then we have another method here. So what I'll do is I'll copy and paste. I'll call it JSON new. Instead of using Marshal, we could use Marsha Indent. So Marsha Indent takes any object, prefix and indent. So prefix is empty and indent we can give 2 spaces. Okay, and we will print the new object. So I'll clear this up and run structs, and if you see, now we have a JSON being printed in a nice indented fashion. This is more like pretty printing the JSON in Go. Okay, we could also define a nested struct within our struct. So what we will do is we already have a struct called employee. So let's create another struct called address. Okay, let's say address has city, which is string, and let's say it has state, which is again a string. Okay, so basically now I have 2 structs, employee and address, and let's say employee can contain address, which is of type address. Okay, so what we could do now is similar to how we have defined this employee, right? We could also define address. So let's say A1 address, and we could supply city, let's say Lowell, and state we call it, let's say MA. Okay, and this address we could supply it to our E1 because we have a field called address, and I assign this A1 here. Okay, so that's all. Now if you run this, let's say we do go run structs.go, you will notice we have John 50 and this is another object. So if you look at the main here, you have address, which was a field name. It's coming from package main, address, value, and even in the JSON marshaled output, we see the address field being displayed. Alright, so this is all I wanted to share in this video. With this we have covered the basic data types as well as composite data types. In the next video we will look into functions, interfaces, etc. That's all I had for this session. I'll see you in the next video. Until then, happy learning.